proceed now to the main topic of your course is the zonal activity or the Lumen method. This is the easiest one because we are not applying a deep knowledge of mathematics. We are not applying trigonometry, and we're just applying purely a formula, getting the average illuminance of your desired space. So what is the zonal activity or Lumen method? But first, you must understand the three main parts of this method. Number one is the zonal cavity. It is used to calculate the average illuminance. This is what I mentioned earlier. And it is used when there is uniform lighting. So what is what we call uniform lighting? Now, if you are using recessed lighting or pin light on the living room, therefore it is a uniform lighting. So all of them, kung gamit ka isa na automatic, kung 5 yung gigamit daw, uniform lighting na siya. So the illuminance at the center of the room can be assumed to be uniform as indicated by the average illuminance values. Walang ni siya ang different from the other methods because we have three methods to be considered: the point-to-point, the other is using lighting fixtures with the multiple sources. But here, we're just assuming that we are using a uniform lighting. So as you can see the ceiling, this is an elevation view picture. So this part is the ceiling, now your secondary ceiling where your fixture, this black part is the fixture or the ceiling, recessed lighting. So the luminaire plane where the light will go here. Okay. Ano siya? Dari ang hayag. Okay, the ceiling part is also your luminaire plane. Then the room cavity, the space of the room. Work plane is assumed this is your table. Now from the table to the floor itself, this is what we call floor cavity. So you have three cavities that we consider: the ceiling cavity, the room cavity, and the floor cavity. And we have also two planes: the luminaire plane where your fixture is installed, and the work plane is the target plane or the task area. Now, ceiling activity, it is the distance between the bottom of luminaires to the ceiling. So the ceiling cavity is equal to 0 if luminaires are surface, mounted, or recessed. So this we are commonly using it. That is why the ceiling cavity is automatic 0. So it will not be a 0 if you are using a light. It's just like a gym or an open space with no ceiling or secondary ceiling. But here, commonly in the buildings or any offices or establishment, we are using automatically surface mounted or recessed. So your ceiling cavity is automatic 0. Next is the room cavity. Room cavity, it is the distance from bottom of luminaire to the work surface. So the height of work surface for different activities will be assumed as follows: 30 inches for offices, so 36 to 38 inches for counters, 4 to 48 for store shops, then 0 for corridors or carpet stores. Now, if you are asking what or where do we get that kind of method, the zonal cavity Lumen method calculations is from the IAS procedures, or the IAS is Illuminating Engineering Society. It developed procedure for calculation of the average by using the zonal cavity. And by using IAS procedures, we include the 11 steps. But the spacing criteria, I did not consider this under your course because this is a deep mathematical analysis. So we just only consider the 11 steps. Now we will now proceed to the step 1. Step 1. So we will determine the generic type of activity. So to determine its luminance category, you need to do that. So we have type of activity, public spaces with dark surroundings. So this part is we have the illuminance category from A, B to C. Then the performance of visual tasks of high is we have D, E, F. So from high, medium, and low. Where GHI is performance of visual tasks of low contrast and a very small size over a prolonged period. So you can see this is an occupancy, this is a working area, and this is sometimes you can consider that as working stations. So we have illuminance category from A to C, D, E, F, and GHI. From the range of illuminance, we can use lux or foot candles. It depends on your preferences. Lux is for SI and foot candles is for English. So you have boundary here. We have 3 levels from 20, 30, and 50. While if you are using foot candles, it is 2, 3, and 5. For reference work plane, since we are on the part of designing, we are not familiar or we are not considering what type of furnitures you use. So for general, we are using the general lighting throughout spaces. If you are for occupancy, for offices, or commonly for task users, it is illuminance on task, or we can preferably on the height of the table. Then this is last part is the illuminance on task obtained by combination of general and local. Now this is part of a working station, just like repair shops, workshops, and laboratory. So if you're done, if you're familiar with this table, we can now proceed to step 2. Step 2 is we determine the range of illuminants from this chart of IASNI. So this is the range of illuminants as earlier. So it's very easy. We can proceed to step 3. Step 3 is this is the table for every category. So using table A or B in figure, determine the weight factors applicable to the illuminance category selected. So remember that A through C, this is what I mentioned about occupant. So room and occupant characteristics, diri mosulod ang inyong condominium, housing, or any occupant spaces na dili magpundo ang tao or depende kung kanusa siya magpundo. And the occupant ages, you need to consider also. But the weighting factor is na siya grading. -1, 0, and +1. Then the room surfaces reflectance, you can read B here if you are questioning about this. So we have greater than 70% or room surface reflectance. So kung saan niya pag-reflect, if nakikina-consider na ang salog ba o ang yang wall is glossy ba siya or hayag, so there's a possibility na dali ang lighting distribution na 30 to 70% and less than 30%. Remember that age gap or age level has requirements of light na yang kailangan na ihintay. So that is why kung naiuban na ang bata gusto siya kay hayag, wag ikaw adult na ka, is tama lang, you like the warm white theme of a restaurant. Then if you are old type na, you're just over 55, you like dark pa. So this is how we understand the lighting preferences of each persons. So if you are designing restaurants, libraries, then you must consider this table. Now for the categories D through I, we have task and worker characteristics. So this is the type for classrooms, just like a factory or anything. We have a task and working characteristics. So we have also a weighting factor. We have -1, 0, and +1. So workers' ages need also. Then speed and accuracy, we have also considered that. Not important, and critical. Then greater than 70, under 40. Remember, kailagayo kayong bata. Ang bata-bata noon pa. 40 to 55, murag grabe na, padulong na siya. Then over 55. Now, if you're very familiar with this table, there's a basic computation. So, you need to add the weighting factors algebraically. So if the sum is negative 2 for categories A through C, or negative 3 for categories D through I, you must use the lowest of the 3 Illuminance values. Asa man kita ng 3 Illuminance values katong kaganina na table sa step 1 and step 2. So Illuminance tables is kaning lux and foot candles. So muna ni 20, 30 and 50. Let's assume that. So let's go back. So if it is negative 2 and negative 3, use the lowest of the 3 Illuminance levels. So among the 3, 20, 30, 50, the lowest is 20. If kato siya mumit sa iyahang requirements. Now, if positive 2 or 3 for the same respective category ranges, you must use the highest Illuminance value. So balik tayo dito sa table. Positive 2 and 3, you will now use the highest, 50. Okay? Now, the other one is, if otherwise, use the middle Illuminance value. If ever naka other numbers or other values other than is negative 2, negative 3, positive 2, and positive 3, now you will use the middle Illuminance value. Okay, so we'll have the example number 1. So based on the right side, you can use still this because this is our guide. So the first example is what will be the weighting factor and illumination level category is E. So it was indicated in the figure, noting the following: age is 56. Then the importance of speed and accuracy is important, so there's a label. Then the background reflectance is medium contrast, about 40%. So what will be the answer? So easy. So the age is 56, then factor plus 1. Sir, asa na siya gikuha? Let's go back again to the table. As you can see, 56, and it is under category E. So we are using the table B. Categories D through I. So 56 man siya. So positive 1. So positive 1. So importance of speed and accuracy, it was indicated that it must be important. Let's go back to the table. So important. So it must be, the weighting factor is 0. Okay, 0. Then the background reflectance is medium contrast, about 40%. So let's go back. So kung 40%, it is between here. So 30 to 70%. Therefore, nadiri ang nakasulod ang 40. So 0 ang value. So plus 1 plus 0 and plus 0, the total sum of factors is positive 1. So in accordance with the table 1B instructions, kung ganina, it is under otherwise, use the middle Illuminance value. So dili mo siya negative 2, dili siya negative 3, dili siya positive 2, dili siya positive 3, was positive 1. Kung positive 1 siya, balik ta dito sa katong original na table, and it is under category E. It was indicated. Then automatic, if you are using foot candles, it needs 75 foot candles, while it needs 750 lux. Okay? So, sir, why you're using 750 and 75? Because the value is other than negative 2, 3, 2, and 3, and it was negative 1, positive 1, therefore you will use the middle value. So, the final answer for that example number 1 is 75 foot candles for the task, or 750 lux. Okay, so let's proceed to step number 4. So step number 4, you must select a suitable lighting luminaire. But this is the time that you will use your electrical and brochures that I assigned to you individually. So you made the manufacturer's brochures based on your own perspective. So diri na ninyo maggamit katong inyong gibuhat na plate. So just to review, we have a classification of light fixtures according to insulation method. Number 1 is the freestanding or portable. Next is the fixed. So under the fixed, naladagan na kayo tadya, recess, surface mounted, pendant, sconce, track lighting, under cabinet, emergency lighting, high and low bay lighting na siya sa street or outdoor outdoor purposes, strip lights, and soft fit. So it's architectural lighting. Then we have also the type of light fixtures according to the percentage of light output depending on what is your trip. If you want to use direct lighting, labon ka itong mga task, labon ng writing or reading, we have direct. Semi-direct lighting is katong sulunod dira mga strip lights. General diffuse lighting is katong sa mga gyms and sports. Semi-indirect lighting is for ambient lang or lobby. Indirect lighting, they are similar. Then we have also the lighting fixtures classifications according to the building. Now A7, if you are using highly Philips and GE na mga lighting brands, they have tables for every building or space type. Now if you are done with the step 4, you already decided what type of fixtures you use. Now let's proceed to step number 5. We need to calculate the room, ceiling, and floor cavity ratios. So here we have HCC, HRC, and HFC. This is the height. Though this is very easy because we have formulas. So number 1 is the room cavity ratio will be calculated as follows. We have the RCR equals 5 HRC, or the room cavity height plus length plus times length plus width of the room. Therefore, if you are using square room type, you can use this formula, 10 HRC over W. While if you are having irregular shape rooms, you will use 2.5 the cavity height times the cavity perimeter, then area of the cavity base. Okay, remember that you must be familiar with this plane. You need the cavity height, then the cavity perimeter. Next is the ceiling cavity ratio or CCR. So CCR can be calculated by getting the ceiling cavity height times 5 length plus width and length times width. But if you have the value for RCR, so you can use the ratio of the ceiling cavity height over ceiling of the room cavity. Okay, HCC over HRC times the room cavity ratio. So this is the other formula. Now for floor cavity ratio, still we have the same, but you can use the RCR, but the ratio now is HFC over HRC. So balik-balik lang, kita ninyo, balik-balik lang siya, pero mas dako reference ko na kay RCR. So better to get the RCR first. So note, for square rooms or irregular rooms, calculate the RCR. Okay, there's a note here, RCR dyan ang una ninyo isolve. Okay, RCR. Then use the ratio of the cavity heights to determine CCR and FCR. Okay, don't forget that we have a constant. So the height of the ceiling cavity, it must be 0 if you are using surface mounted or recess fixtures. Okay, now let's have an example number 2. Example number 2, if we have an open space 3 meters by 4.6 meters with a 2.6 meters ceiling height, determine the room cavity ratio assuming a work plane height or katong table siguro na yung napasabot, having a 0.76 meters, typical desk height. So let's go to the solving. The room cavity height must be solved with the luminaire height minus work plane height, which is HRC. So if we have value, okay, 2.6 the ceiling height, meaning dira tong plane kung asang suga nagsugod ug kakahayag. So that is why 2.6 the luminaire height. Then balik ta. Then the work height is 0.76 katong table. Therefore, your room cavity height is 1.84 meters. So the luminaires are recessed in the ceiling, so the luminaire height is the ceiling height. So computing the room cavity ratio, we have RCR, so 5 times room cavity height, which is 1.84 meters. The length in width is 3 times plus 4.6. So your answer is divided by 3 by 4.6 meters. So asa na ko na siya gikuha katong formula ka kanina. Ano eh? RCR. Okay. So times the RCR is 5. Then you can use now katong ratio. Remember the note earlier. Now you get the CCR equals to 0. Then FCR is 2.1. So you have the 3. So after getting the RCR, you can get now your CCR. You can get your CCR and your FCR. You got the 3 values for that. Okay, so step 6. Okay, we have 5 steps more. Step 6 is we need to determine the room surface reflectance. Saan na siya? So this method assumes that you can determine the reflectance of the major surface of the room. So two reflectance will be determined, the actual and the effective reflectance as follows. So sa man tong mga reflectance sa imuang lighting fixtures. First one is the cavity surface reflectance. Katong sa sulod sa cavity, which is the ceiling, the walls, and the floor. So they can absorb or they can bounce off the light again to each cavity. So you have 3 values as follows. So RC, RW, and RF. This is cavity surface reflectance. The next one is the effective cavity reflectances. So do we have the effective ceiling cavity and effective floor cavity? So nawala na siya ang wall because some of the walls are not considered reflectance of the light, kay ceiling o floor man jud ang gina-consider, and they are very effective way to consider on the solving of the Lumen method. So you must determine the ceiling, wall, and floor reflectance values. So we have here, if your ceiling is in a standard white paint, you have 80%. If you have rough white paint for ceiling, you have 50%. So dili na siya, depende sa trip sa inyong pintor or sa inyo ang gustong gamitong pintura para sa inyong suga. Remember, they are one of the factors on distributing the light on your space. Now, if you are using wall white paint, we have 60%. Okay? Then, rough light paint, 30%. And concrete is 40%. Then, floor, if you are using dark concrete, it's just only 15%, and carpet, average. Then, if you need more tables like this, you can download or search the tables of different organizations like IAS and A table for typical approximate reflectance. Okay, that is note for you guys. And next is the step 7. I already mentioned about the coefficient of utilization, but there's a computation for this. So factors influencing coefficient of utilization is number 1 is the luminaire distribution, the geometry of the space or the length width of the space, and the reflectance of the room surfaces. So we have the 3. Okay, so these 3 factors will affect the efficiency of the luminaire. So let's take an example number 3. For example number 3, for a room cavity ratio of 1 and a reflectance of 30 for ceiling, 30 for wall, and 20 for floor, you will need to determine the CU for this luminaire. Remember that the room cavity ratio must be computed. So, na may formula na. But, depende sa inyo. Kaning reflectance will depend on you. You as a civil engineer or an architect to use this for getting the coefficient of utilization sa inyong table. So, determine the CU for this luminaire and use the reference table below at the right side. So, if you are using room cavity 1, if you are solving, you have the value 1. Then, kung sa ceiling cavity kay 30, so let's go to 30. Ang wall nimo is 30. Then, wala man siya floor. Here is just a cavity for ceiling and wall. But here, there's a coefficient of utilization for 20% effective floor cavity reflectance. So, this table is intended for 20%. So, daghang kayo mo makita na aning table sa IESNA sa internet. Now, you can get the coefficient of or ZU for 63. So, CU equals 63. So, what is the interpretation of 63? So, the interpretation of 63 is, which means that the 63% of the lumens given off by the lamps reach the work plane, and the other 37% are absorbed by the luminaire of the room surfaces and never reach the work plane. Okay, understand? 0.63, 63% of the lumens given off by the lamps reach the work plane, and the other 37% are absorbed by the luminaire or the room surfaces and never reach the work plane. So, mo na siya ang CU. Meaning, if you have 100 watts, then 2,300 lumens, then you have only 63% of that nyato dito sa imong table. The rest is lahi na padulong ang kahayag. Now, let's proceed to the example number 4. Continuing with the examples number 2, namtay mga data kaganina. The following assumptions are made after consulting the IESNA Lighting Handbook table on effective reflectances. Earlier, we have 0.70, wall reflectance na 0.50, effective floor cavity na 0.20. Now, determine the CU for this luminaire. So, kani, natay guide, 70, 50, and 20. So, let's go back daw sa katong kaganina. For example, number 2, I think ang RCR kaganina na is 1. So, let's go to the table. Okay, the answer is RCR is equals to 5. So, okay, the RCR is equal to 5 calculated in example number 1. Example number 1 is connected to the example number 2. You can play back on that part to check. The RCR is 5. Then, we need to consult the lighting handbook. Ang CU daw is 0.50 daw. Let's check. 0.70, 0.50, and 0.20. So, let's go to the table. So, 0.20 daw, then 0.70, okay, here, then 50, then cavity niya na 5, wait lang, I will make a pen. 20 daw ang floor, then, yeah, ang ceiling cavity is 70, then wall reflectance is 50, then room cavity is 5. So, let's check again. ceiling 70 and wall is 50. Ceiling 70 and wall is 50. So the answer must be 41. So let's check. I think it is wrong. Oh, it is wrong. Dapat it must be 0.41. Okay, since RCR is 50. Room cavity. So 5. So asa niya gikuha ang 50? Sig na siya, nasaag siya. Okay, the answer must be 41. Okay, 41. So you can download the tables for lighting, for coefficient of utilization for different luminaires. So each luminaire has its own CU table specific to that luminaire's light distribution. So that is why naghibuhat mamong brochures katong plate number 3 man ata to, plate number 2. Now you can search that brand on the internet if there's a table specific or light distribution data na ilang gi-provide. Okay, so CU values are listed in tables for different room geometries and room surfaces reflectance. Step number 8 is calculate light loss factor. So these are the two types. Earlier, I already mentioned about recoverable and non-recoverable. Recoverable is the relamping and recleaning. The non-recoverable is okay, katulad jud, di na jud siya may list. Ilista na jud siya. So total light loss factor is the product of the individual light loss factors na recoverable and non-recoverable. So detailed description of the determination of the light loss factors can be found in the IESNA Lighting Handbook. Dito ninyo makitaan. Now let's proceed to the categories sa recoverable LLF. Okay, recoverable LLF, dira mo sulod si LLD, lamp lumen depreciation or the maintenance factor, lamp burnout factor, the LBO, the luminaire dirt depreciation factor, LDD, room surfaces dirt depreciation factor, kung sa kahuka ang salog, part po na siya, RSDD, then the area of the work plane. Okay, let's discuss something about the lamp lumen depreciation. Okay, the lamp lumen depreciation factor is the fraction of initial lumens at a specific time during the life of the lamp. So nana sa table nakabutang pila ang life expectancy of the lamp. Nauban na 5 years, 2,000 lighting period, napo na siya 2,000 operating hours, 500 operating hours. Wala na siyang gina-consider. Lamp lumen depreciation comes from aging and dirt accumulation in lamps, reflectors, lenses, and room surfaces. Most lighting designs base calculations on maintain as opposed to initial lamp lumens. Okay, duwa na siyang gina-solve. Number 1, katong maintained, if ever wala na hilabtan, wala siya naabugan, or katong yung pila ka period na niya ni ngana na exposed, then napud siya isa ka solution na katong initial, itong bag-o pa jud siya gi-install ang imong fixture. The lamp burnout, okay, let's proceed to the lamp burnout factor. The lamp burnout factor, it is if lamps are not replaced immediately after burnout, a lamp burnout factor should be applied to any analysis of the system. Okay, so unreplaced burned out lamps will vary in quantity. Katong mga punder, wala ninyo gilisdan. Diyan ang sulod ang lamp burnout factor. It is depending on the kind of lamps and the relamping program used. So, naya na sulod. This factor is simply the ratio of the number of lamps that would be burning, or the total number of lamps of the total number of lamps. Example, na kay 15 diya gi-install, na 5 ka buok dira na mapunda. So 5/15, you have 1/3 na ratio. Okay, for lamp burnout factor. Next one is the LDD, the Luminaire Dirt Depreciation. The Luminaire Dirt Depreciation factor depends on 3 aspects of the situation as follows. Number 1 is the amount and type of dirt in the environment. So let's have an example, a clean office environment compared to a dirty manufacturing facility. Okay, that is the number 1 aspect. The second aspect is the type of luminaire use. The third one is the expected cleaning cycle for the equipment. So, dira na siya. Muna siya mga factors. Now, the fourth one is the room surface dirt depreciation factor. What is that? It is influenced by the amount of dirt in the environment. Labaw na ng abog, mga lawa-lawa. The room cavity ratio proportions to the room. So, type of lighting equipment use. So, these are the influence of the RSDD. While the last one is the area of the work plane. It is the area of the entire work plane or the table, which is typically the same as the floor area. Pero ang floor area magud is wide, but katong task lang na work plane ang katong gina-consider. So, Illuminance will be greatest near the center of the room. Why? Because kung asa to gi-install ang suga, dito man na nagtapok tanan ang light rays. So, that is why ang center dyan ang pinakayag. And slightly less toward the walls for a given uniform layout of luminaires. Okay? So, kadaganan, walls, muna siya ang uban, ginadungagan na lang siya og mga indirect lighting siya like strip lights para madugangan pud ang kahayag. If you need to put some tables or work planes beside the wall. Now, let's proceed to the non-recoverable LFF. So, we have 1, 2, 3, 4, 5, 6, and 7, and 8. Okay, let's discuss about the Luminaire Ambient Temperature Factor. The Luminaire Ambient Temperature Factor, it is variations in the temperature above those normally encountered in interiors and have little effect on the output of incandescent and high intensity discharge lamps, but can have significant effect on light output of fluorescent lamps. Next one is the heat extraction thermal factor. The heat extraction thermal factor is the fractional lumen loss or gain due to the airflow. Hangin na. So, airflow has an effect on lamp temperature and lamp lumens, especially those air handling fluorescent luminaires which are integrated with the HVAC system. Itong exposed sa aircon, kabugnaw. So, as a means of introducing or removing air from the room. So, kailangan siya heat extraction ng thermal factor. Next one is the voltage to luminaire factor. High or low voltage at the luminaires will affect the lumen outputs of lamps. So, high voltage conditions will increase the lumen output of lamps over their rated output, while the low voltage condition will reduce the lumen output. Remember guys, balik ta. High voltage condition will increase the lumen output of lamps. So, what is lumen? Katong biyahang kahayag in a certain location. Then low voltage mo nang musulod na kanang murag kanang sa hotel na mo katong murag volume rack para sa suga. So dira ni mo dulaon ang voltage. Okay, mo siya light controller. So the rate of change of lumen output with the voltage change varies with each light source, but has the greatest effect on incandescent lamps. So we're not dili na kita familiar sa incandescent lamps because we're now using LED. Next one is the ballast factor. Ballast used for specific applications. This is an old traditional type of So that is why that it is a non-recoverable. Pag daot lang ilisdan. So ballast factor mo na itong daan kung yung mga rectangle na putong mga lingin na gagmay na ginatawag. I don't know if nakakita pa ba mo ana na napay ballast ang fluorescent lamp. Then ballast lamp, they are similar. Then coefficient of utilization. So equipment operating factor kani effects on the lumen output of lamp caused by the ballast, the lamp operating position, and the effect of power reflected from the luminaire. The next is the lamp position factor. So the lamp position factor is sensitive to the lamp orientation, especially for high intensity discharge or HID. Ganang ginatilt. So when they are tilted from the rated horizontal or vertical position, so ma-affect mo guna. So namgyan ginabutang mo guna na ng mga street lamp or HID lamp na it is better to use at a certain angle. So pag i-affect nimo siya, naka-apply nimo siya sa for example, the certain angle is 90 degrees but you apply it in the 60 degrees, then there's a lamp position factor. So lamp position factor adjusts the lumen output and it is defined as the ratio of the luminous flux in the given operating position to that in the test position. Okay, the last one is the luminaire surface depreciation. The luminaire surface depreciation results from adverse changes in metal. Katong metal, paint o katong plastic, katong yang covering sa imong suga. So anom dyan na siya, na siya depreciation magdaan. So it clearly affect the results of the lighting output. It reduces the light output. Okay, so let's have an example number 5. Assuming the following, we have number 1, recoverable factors. Ang lamp lumen deposition nato is 0.90. So we have assume this factor. Lamp burnout factor is 1. The luminaire dirt depreciation factor is 0.94. The room surface dirt depreciation is 0.96. Then we have the non-recoverable factors, ballast factor 0.33. Pero pag LED mo gamit, automatic 0. Now, so other non-recoverable factors is 1. Itong other na ng mga circumstances. Now the question is, calculate the light loss factor. How to solve that? We have many numbers given. To get that is just multiply. LLF total is recoverable factors times non-recoverable factors. Multiply all numbers, then you get the LLF total. So get 0.75. So what is the explanation of 0.75? Earlier, we have an explanation of coefficient of utilization. Now we will have an explanation about the LLF. So it means that the 25% of the luminous flux that might otherwise reach the work plane is lost due to the ballast factor, dirty luminaires, room surfaces, and H lamps. So meaning, ang 75% mo to ang ni punta lang nakahayag, then the 25% katong nasayang or na loss. So you can use the criteria developed by the ISNA for getting the approximate value for the LLF total. Okay, now let's proceed to the other example. Example number 9. Calculate the number of required luminaires. So this is the time you will calculate how many lighting fixtures you need to buy, you need to use on a specific location. So to solve, the formula is the number of luminaires, AWP, that is the area of the work plane. EWP is the average maintained illuminance on the work plane. Okay, the flux total and the total system lamp lumen output kani lumens lamp, then lamps, then luminaires. So CU is coefficient of utilization, then LLF is the total light loss factor. Now we have example number 6. find the number of luminaires needed in an office given the following. So you have the office dimensions 9.15 meters by 9.15 meters by 3.5 meters, which means length times width, this is a square, and the height is 3.5 meters. Then the working plane height is 0.76, itong table height. Then we have the reflectance ceiling activity. Remember that we have ceiling cavity na 0.70, walls na 0.30, then floor cavity is 0.20. Okay, so for overall, for the reference of everybody, we will use 0.20. Okay, then assume LLF total, which is 0.75. Now, how to get that answer? So by using the following table, determine the type of activity. So since it is office, automatically it is a performance of visual tasks of high contrast or large size. So it's up to you what category do you want to use, but you need to be consistent. So Illuminance category is D. Okay, step 2 is determine the range of Illuminants from the chart of ISNA. So the range of Illuminants is 200, 300, 500 lux. So for now, you will now use the SI. So D, and we now use the 200, 300, and 500. Now step 3, using the table B in the below, the right side, determine the weighting factor. So we choose the category D, nata diri sa table B. So workers age is 40 to 55, let's assume. Kaya mo na siya ang active na age for the office works. So automatic, your weighting factor is 0. The speed and accuracy weight factor is critical. So let's consider critical, plus 1. Then reflectance of the task background less than 30% gives weighting factor of plus 1. Okay. Then as you sum of the factors, it is plus 2. Therefore, your middle illuminance is considered. Okay, I think it's wrong. So remember, there's a ruling that there's a value for that. Remember that we have a value of positive 2. So we will not use the middle illuminance because we have this condition. So plus 2 is we need to use the 500 lux because it is a positive 2. So therefore this is wrong. So your answer must be 500 lux. Okay? So gituyo ko ni siya para kung dili mo tanaw video, mamali jud ka. So this is how I teach. So you need to follow or watch this video to get the right answer. So since we are done with the step 3, we'll now proceed to the step 4. Select a suitable lighting luminaire from the manufacturer's catalogs for the activity and place under design. Remember that from the step 1 until step 8, kanina example is we are applying all the steps. So let's say I select the recessed round and the specification for that is 70 watts metal halide. Then according to the specifications of the brand, na siya 5,600 lumen na output. So nanakoy napilian na fixture. Step number 5 is calculate the room, ceiling, and floor cavity. So naman tayo width and room, which is 915 meters. HCC is 0 because it is recess, remember. Then the height is 0.76. Then room cavity is 3.49. Then 0.76. Sir, di ba 3.5? Consider 3.49 kay naman dyan na siya allowance na 0.01 kay kanang niyang thickness sa mga ceiling materials. So depende po na mo kung 3.5 but I consider 0.01 na thickness or the width of the materials na gamit sa ceiling. Now your HRC is 273, so 0.76 for HFC na po kay HRC na 2.73. Now you will apply the formula. So first you need to get the RCR. Now dyan yung first step. So to get the RCR, since it is a square room, so you have this solution. So your RCR is 3. To get the FCR, applying the ratio. So RCR, FCR is 10, okay, 3, then you get the 0.83. Okay. Next is determination of room surface reflectance. So given an input data, so let's use this constant. You have 0.70 sa ceiling cavity, wall cavity nimo 0.30. But remember na kay RCR, pili mo RCR kaganina, is 3. So let's go to the table. So based on the reflectance below, gamit kani ceiling cavity 0.70, that you have the effective. So after that, getting the effective, determine the coefficient of utilization. So your CC, remember, that's 70. Your PW is 30. Your RCR is 3. Then automatic, your CU is 0.75. Okay? Muna siya makita ninyo na katong polar o linear luminous intensity sa mga specifications of every lights. So makita ninyo kung saang shape siyang hayag or iyang drop. Kuwasa niya kutob. Muna siya ang katong tagak niya na shape sa suga. Okay? So kung tinuna siya, kung actual na, if this is the ceiling, dire na yang mo na siya ang yang dire, yang shape sa yang hayag. Then the rest will be the distribution of lighting system. So oblong from 0 to here. Okay. Step 8. Calculate the light loss factor. Given an input data that LLF total is 0.75, and it was indicated already. So, itong ganina sa problem. So, nana tayo value. Step 9. Calculate the number of required luminaires. So, this is time that you will solve the luminaires. So, ALEWP, EWP, Lumens lamp, lamps luminaires, and CU LF total. So apply all the datas. You have 9.15 meters, 9.15 meters, then 300 lux. But it must supposed to be 500. Okay? Then 5,600 lumens katong specifications times 1. So asam ng 1 gikan. Remember that it is for every lamp, 1 lamp natay 0.55 and 0.75. Asa po na siya? So imuang CU and LLF. So 1 lamp lang ka. Consider. Then you get, wait lang, let's solve that. 9.15 times 9.15 times 500 divided by 2600 times 0.55 times 0.75. So based on this answer, if this is 500, so it must be 18.12. So probably you are using 20 fixtures. So if it is 300 lux, 12 fixtures. If 500 lux, we are using 20 fixtures. Sir, why you are not using 19 or 11 instead? We need to be space it uniformly. So from 10.19, if you round off, it is 11. But how can you, the question is, how can you space it uniformly? So you need to make it 12 so that you have a pattern 3 by 4. While these 20 fixtures, you can pattern it is by 4 by 5 pattern. So this is the way on spacing patterns. So if 10.9 using the 300 lux, 12 is more than the calculated value of 10.9. So results within the 10% margin. Sometimes we are considering the 10% margin. Okay, so 18.12, the 10% for that is 1.8. So 1.8 comes round off to 20. Then step 10 is calculate the total system plump lumen output. So get the lumen output, the numbers of luminaires, the number of lamps per luminaires, lumen of one lamp. So the sideline example, this is not connected anymore on the problem earlier. So that is what we call sideline example. Okay, this is a sideline. This is not connected because we are already done with the problem earlier. Okay, so the sideline example is 3 by 4 daw with a 2.6 meter ceiling height. There are 2 recessed fluorescent luminaires. Each luminaire has 3 32 watts, meaning ang luminaire ana is ingani. At the top view, this is your fluorescent luminaires na ay 1, 2, 3. Muna siya sa mga office. Then na kay fluorescent tara. So ballast type, let's assume this is an old school. So nakay luminaires dara. This is the fluorescent, then fluorescent. Okay, kani siya ang katong housing sa kilid. Ya mo ni mo ang fluorescent. Tulo. So duha daw ka booking ani. 2 sets. So 3 32 watts, so taga pumbilya, taga fluorescent is 32 watts, 48 inches ang kataas, and it is specified as T8. Manufacturer's data shows that the initial lumen output katong imong pagpalit pa lang na siya, nagingon na siya daan 2,900 lumens daw initial. The question is, what will be the total lamp lumen output, the flux total? So as you can get, the formula is pila ka buok ang gigamit na luminaires? 2. Number of lamps, meaning tulo ka buok lamps, meaning tulo ka bumbilya per luminaire. So per luminaire, 1 luminaire is katong imuang fluorescent luminaire o katong housing. Then 2009 lamp katong imuang lumen output, katong iyahang lumen output of the lamp per fluorescent lamp. So ang 32 watts magahatag siya og 2,900 lumens. So that's why 2,900 lumens per lamp. So you will get the 7,400 lumens. Okay, muna ang igihatag na hayag sa duha ka buok na fluorescent luminaires. Step number 11 is calculate the illuminance on the work plane. Question na po, ang step 10 is pila ang lumens o kahayag na gihatag sa katong lighting fixture. Karon ang step 11 is ang illuminance towards the work plane. So you already get the total system lamp lumen output earlier, then get the CU, LLF, then AWP, area of the work plane. Now substituting all the computed values in example 2, 4, 5 in the previous article or previous slide, then example number 7 in above, and using the equation for average illuminance of the work plane, we have, for example, 7,400 lumens ang ganina gisolve, then apoy 0.50, 0.75 katong mga data gigamit ito kaganina. Then we have sama ng formula CU and NLF, then divided by the area of the work plane. So laman gi-indicate ang area sa work plane, but earlier we can use this data, area of the work plane. So you get 468 lumens per meter squared, meaning you have the 486 lux maintained. So if this is your table, okay, if this is your table and this is the light, therefore ang hayag na padulong dere is 486 lux. Okay, so the average initial illuminance of the work plane can be determined by substituting only the non-recoverable light factors para makita nimo ang initial. So kaganina 7,400, 0.50, then katong LLF imong gamiton na the non-recoverable, so 0.93. Sorry for that, 0.93. Still the data. Then initial, meaning kaning non-recoverable yung gamit katong bagko jud siya, wala pa siya nakaagi o katong mga abog-abog. So therefore kung initial katong bagko pa jud ang imuha, that is 581 lux. During the operation, habang ginagamit siya for how many months operations, ang maintain niya lang niya is 486 lux. The average maintained illuminance of 468 lumens per square meter will strike the area covered kani. Okay? Katong covered kani in a plane. Some points on the work plane will have an illuminance higher than 468, while others will have an illuminance lower than this value. So during the first time that the system will be turned on, so muna turned on 581 lux, the system will, wherein the lamps are new and the surface are clean, the average initial illuminance will be greater than the maintained value, which is computed as 582 or 581 lumens per square.